Hello and welcome back, it's Peter here, Piotr Fissner. How you doing, guys? So, we've got a part 3 and we've got a problem which I will explain. I will give you my point of view and you can decide if I'm right or wrong. So, this is the third part of the Logic3. The model is there, TX101. Irrelevant. What I want to say is we've replaced two diodes. Here is these diodes and the fuse, which is not too nice. But anyway, let's forget about this fuse for now. Yes, this bridge was as well done. So those were things done. Now this don't have a full power, and I don't see a diode for the standby. So I follow the circuitry. Okay. Now, the whole problem is that usually standby is like 3.3 volts nowadays. Yes, before were different, but nowadays it's about that. So, when the standby is passed on later to the main board or some other controller on the main board, then this signal goes to the button and you press the button and you can switch it on. It has a feedback, and then through the opto-isolators signal goes and turn on the whole power supply. This is a switching power supply. Yes, not the best solution for the audio, but whatever. What I want to say is, okay, so we know how it's working. Yes, but we need first this standby voltage, which here is a problem. So what I found out that these here and chip goes from here to those. So I'll show you under the microscope, but before I'll do it, I want to show you one thing. Here's my meter in the diode mode. Beep beep. Yes. And now I'll check. I know you don't see because it's too bright, but okay, so we get ground, which is ground is here, and here is a standby. So 5-volt aux is shorted to the ground. So we would say that that can be 5-volt regulator. Let's say, so maybe it's 5 volts, maybe it's not that. But here is the standby which is growing. So it maybe wouldn't be the short on the standby, you know, on this circuit here, standby circuit, then maybe it would go back. So then again ground. Yes, and I don't see any other shorts, only on the 5-volt auxiliary. Mute, nothing. Okay, now ground VCC, nothing, it's charging well, and VE charging well, so it's okay. Yes, the same here, ground to VCC, nothing, perfect. Second ground to second, perfect. So everything else is growing. So only the problem is with a short on the 5-volt. What's written here, 5-volt auxiliary. Yes, and we got a break in the base. So now I show you what I've seen as well under the scope. Well, I didn't look at the scope until I made this video. So let me switch webcam. Let's switch off. This is on. Let's turn on the light. Look, even the enclosure here is damaged. Yes, so this chip SOP8 packaging, you can see IC5 it's written. Well, the problem only is that this IC5 don't have anything on itself. So I can only assume that that's the 5-volt regulator, because here what we can see is 5-volt aux, okay, and the standby. So I've checked the circuitry, and this 5-volt aux, it's responsible for the problem, I'd say, and that's why we don't have the standby voltage. Okay, that's my way of understanding the circuitry, but hey ho, I'm no expert. I'm fixing everything. Yes, but I'm no expert. So I've asked myself what I would do if that would be my stuff, and I said to the customer, look, yes, either we will take out that chip, yes, and try to replace it with anything else which can produce 5 volts on that line, and see what we can do about the standby voltage, yes, blindly, yes, blindly, or we will take another power supply like that, replace it with, if possible, as well measure so that we can replace with proper components. If we see some voltages or something else, we could fix it by taking like any 555 or something. It's like depend what it does, because we don't know. I can only guess what it does. So yeah, I might be talking complete rubbish, or I might be spot on. Yes, so I don't want to guess. I don't want to put customer in a position like, oh, maybe let's do this, maybe let's do that, but why? Yes. And so I said, or yes, or just try different, completely different power supply. It's a switching one, so it's not a dear one. Completely different, and then get those extra signals as well. Mute, it doesn't really matter about the mute. It's cut off voltage to be true, so it's fine. You don't have to have a mute. What else we had over there? Standby, well, standby of course. LED, well, better to have LED than not, but it's not a problem, because getting standby LED and regular LED, we can do it no problem. BY, I don't know what BY stands for. If anybody can tell me, brilliant. By ground, of course, self-explanatory. A mute, we don't care about the mute. And IR, infrared, I don't know as well. If somebody can tell me, brilliant. That's how I see it. Yes, I would replace this power supply, and the second row of things over there is VCC, ground, VEE, so that's for the voltage. That's okay, that's easy peasy lemon squeezy. 5 volt is not present here, and this wasn't connected, and here we've got VCC, VE as well. Yes, so that's okay. The rest is fine. The rest is easy to figure out. But yeah, those PY and those, the second one, yeah, IR. If somebody would have the second one, that would be easier. Yes, but now we have to guess. So I need to leave customer with that decision. If customer want to risk anything, or forget about it, or do whatever customer wants, because to be true, I've got a Panasonic Home Cinema which I can sell him for like 60 quid. Yes, and that's Blu-ray, 3D Blu-ray with a remote. It has an optical coaxial aux, you know, like everything customer needs, and radio built-in. Yes, so it's up to the customer with a subwoofer even, or put some money in it and then risk it if it will be fixed or it won't be fixed, because I can only guess. I cannot guarantee the outcome, because I can only guess things, and when I can guess things, it's not professional. Yes, so customer has to make the decision. I don't mind to give a hand, I don't mind to, you know, like spend time on it, but if customer don't want, I need to accept it. If customer want to put some money into this, I need to accept it. Yes, so at the end of the day, that's all the diagnosis. until I won't have that signal, I can't go further, I can't do anything else, because the everything else stuff is wrong anyway. Yes, maybe we will fix it and maybe will be more faults, or maybe we'll fix it and will be no more faults. Yes, we don't know that has to be first fixed. So that's it, guys. If customer will make a decision to continue, I'll record more episodes. If customer will decide to not go any further, that's okay. The worst case scenario for this device is that I could take out this, see if I can get voltage, if I could get other voltage, or see how it's built, and overcome the standby and have it always on and only on this here. Yes, on off button. Then what I could do is I could get amplifiers, yes, and then line in for something, but that would be only stereo, you know. I wouldn't do Dolby Surround or 5.1 or 7.1 or whatever it has. Yes, I wouldn't do that because the cost would be quite high. So I can only offer to the customer that if customer don't want to fix it properly or don't want to take a risk, then we can put, I got the class D dual channel 30 watts. We could use that one as an amplifier and you know, supply the voltage to it. That's us. Sorry that I couldn't fix it any quicker, any better, and you know, I need to guess things here. I can assume what it is, I can, but yes, but it's not professional again, so I won't be doing it, and that's why I need to leave it to the customer. So thank you for watching, see you in the next one. If you did like those 3 parts of the Logic 3 analysis, how I'm doing it, please leave us a like button if you haven't already. If you did, here's likes to use. See you in the next video, and if possible, let's fix them all. Take care, bye bye.